Lecture 8, Elasticity Part 2, Cross-Elasticity and Income Elasticity. I was walking on campus today and I saw this young man with the sign, and it had the two words in it that are four-letter words that you should never use in economics: free and need. I wanted to take a pen and just put quotation marks around free and quotation marks around need, because you know that nothing is free. There's a cost to everything, so it's free, quote unquote, and you don't need anything because there's a substitute for everything. So here are some of the classes that have been inducted in the last couple years into the Royal Order of Tonstoffel. Notice they give the greeting of supply and demand. We're moving on to Elasticity Part 2. Let's do a quick review on the 5 tests of determining elasticity of demand. So we'll look at products that have an inelastic demand and an elastic demand. If it's inelastic, then it usually has few substitutes, and if it's elastic, it has many substitutes. If you can't figure it out from test 1, go to test 2. Test 2 is, one is a necessity, the other is a luxury. If it's inelastic, it tends to be a necessity, and if it's elastic, it tends to be a luxury. Expensive and inexpensive. If it's inexpensive, it tends to be inelastic, and if it's expensive, it tends to be elastic. So if you double the price and it's inexpensive, people aren't going to change their buying behaviors very much. They're still going to buy the product. Let's say the product costs $1 and now it goes up to $2. It's not going to change their buying behavior all that much. But if it's expensive, and let's say it's $20,000 and the price doubles to $40,000, then people are going to reduce their consumption by quite a lot. If you can't figure it out from test 3, then definitely you should be able to figure it out from test 4, and test 4 is the total revenue test. The total revenue test for inelastic is if the price goes up and the total revenue goes up, then it's inelastic. If the price goes down and total revenue goes down, then the product is inelastic. Another way to explain it is if the price goes up and the total expenditures goes up, it's inelastic. And if the price goes down, then total expenditure will go down. Don't forget, total revenue is equal to total expenditure. Total expenditures are the expenditures by consumers who then pay the producer or the supplier the revenue that the supplier or the producer receives. So TR is always equal to TE. If it's elastic, then when the price goes up, total revenue goes down, and if price goes down, total revenue goes up. Good way of figuring out elasticity of demand is to just use the total revenue test. But the 5th test is really the way you figure out what is the elasticity of demand for a product, and that is called the elasticity coefficient. So we're going to give you the answers here for test number 5. If once you plug in all the numbers correctly and your elasticity of demand coefficient is less than 1, then the product has an inelastic demand. If the elasticity coefficient is greater than 1, after you've plugged in the numbers correctly into the formula, then you know that the product has an elastic demand. So you must understand the formula for elasticity of demand to determine whether your product has an elastic or an inelastic demand. Let's go over the formula. An English teacher would write it out in this manner. Elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. But in economics, we like to use symbols and abbreviations, so let's simplify this. Elasticity of demand is the percentage change, or delta, in quantity demanded divided by the percentage change in price. This is the formula we're going to use to figure out elasticity of demand of a product in the marketplace. By looking at this formula, How do you figure out the numerator? Go ahead and pause this video and try to figure out what the formula would be for the numerator. To figure out the percentage change in quantity demanded, you would take the change in quantity demanded from one quantity demanded to the next and divide it by the original quantity demanded. Remember that when you're figuring out the numerator, which will be a fraction, just like Coors, always use the original. So whatever your starting point is, that's the number you're going to plug into this formula. If you know how to figure out the numerator, then how would you figure out the denominator, percentage change in price? Go ahead and stop the video and give it some thought. If you're trying to figure out the percentage change in price, then the formula for that would be the change in price going from the original to the next price divided by the original price that you started with. Just like Coors, always use the original. We have the formula then of elasticity of demand is equal to the change in quantity demanded going from the first quantity demanded to the second, so whatever the change is, divided by the original quantity demanded, divided by the change in price going from the first price to the second price, and then dividing by the original price or the first price. What we have here then is a fraction divided by a fraction. Let's simplify this one last time. Elasticity of demand then is the change in quantity demanded divided by the original quantity demanded, so you'll circle that, times price, the original price, divided by the change in price going from the first price to the second price. There are 5 steps in figuring out the elasticity coefficient. Number 1, always write down the formula. So let's write down the formula. It's the change in quantity demanded divided by the original quantity demanded times P over the change in P, and this is always the original. Make sure you always write down the formula. Number 2, do not use negative numbers. We're going to use absolute numbers. So let's say that the change in quantity demanded goes from 100 to 90. That is a negative 10. Because we do not use negative numbers, we're going to always use the absolute value. So there'll never be a negative number inside your formula. So number 1, write down the formula. Number 2, do not use negative numbers. Number 3, always fill in the original numbers first. So fill in the original quantity demanded and the original price. Once you do that, then go to step number 4. Fill in the other 2 numbers. Subtract the second quantity from the first quantity to get the change in quantity. And for the change in price, take the first price and subtract the second price. Make sure you always use positive numbers. Do not use negative numbers. And then you filled in all of the numbers. Once you fill in all of the numbers, then the originals for the original quantity and the original price, and then the other 2 numbers, which is the change, fill in the change from quantity 1 to quantity 2 and from P1 to P2. Now you can come up with the answer. If your answer is greater than 1, then the product has an elastic demand between those 2 price ranges. And if your elasticity of demand answer is less than 1 between those 2 price ranges, then you know that the product has an inelastic demand. We're using what's called the simple elasticity coefficient numbers. We aren't getting into what's called midpoint elasticity or arc elasticity. We call this the simple elasticity formula. Let's look at a linear demand curve. As you notice here, the price of widgets goes down by $1, which as it goes down by $1, the quantity demanded for the product goes up by an additional 40 units. The question then is, what is the elasticity coefficient going from $2 to $3? Take out a scratch piece of paper and see if you can figure this out. Go ahead and pause this video. Looking at the price and quantity demanded of widgets, you notice when I lowered the price, the quantity demanded goes up. And for each dollar decrease, the quantity demanded increases by 40. What we're going to do is figure out the elasticity coefficient going from $2 to $3. So go ahead and pause the video, take out a scratch piece of paper, and figure out what the elasticity coefficient is going from $2 to $3. If you look at the gray type inside the slide, you can see that you must write down the formula. So let's write down the formula again. It is the change in quantity demanded divided by the original quantity demanded times the price over the change in price. We're going from a price of $2 to $3, so the price is 2. And the quantity demanded, the original quantity demanded, is 320. The change in quantity demanded is a negative 40. Remember to use absolute value, so that would be 40. And the change in price is 1. When we multiply this out, we get 80 over 320, which gives us 1/4, which means it is 0.25. Is the demand between the prices going upward $2 to $3 elastic or inelastic? The number is less than 1, so if elasticity of demand is less than 1, we know that the product's demand going from a price of $2 to $3 is inelastic. Let's do it the other way though. Let's go from $3 to $2 and see if the elasticity coefficient is the same. So go ahead and pause this video and see whether or not this is the same elasticity of demand coefficient. Remember, when figuring out elasticity of demand coefficients, take the change in quantity demanded divided by the original quantity demanded times the price, the original price, divided by the change in price. We're going from $3 to $2, so the price is 3. The quantity demanded at the original is 280, so let's go ahead and put in 280, so we have the originals first. The change in quantity demanded is 40, and the change in price going from $3 to $2 is 1. So we get 120 over 280, which is then 6/14, which is 3/7. As you can tell, the answer is less than 1, and so the elasticity of demand is still inelastic as you lower the price from $3 to $2. Let's look at a different situation on the same demand curve. What is the elasticity coefficient going from $8 to $9? Go ahead and pause the video and figure this out. Remember to always write down the formula. The change in quantity demanded divided by the original quantity demanded times the original price divided by the change in price. The original price is 8. So we have an original price of 8. The original quantity demanded is 80. The change in quantity demanded is a negative 40. Make sure you use the absolute value, so that would be 40. And the change in price going from 8 to 9 is 1. So we have 320 over 80, which is equal to 4. We know then that the elasticity of demand is greater than 1, and between the price ranges going up from $8 to $9, we know that the elasticity coefficient is 4, so that means that between those two price ranges going in an upward direction from 8 to 9, that it is elastic because the number is greater than 1. But how about if we go the other way? We go from $9 to $8. If we go from $9 to $8, go ahead and figure out the elasticity coefficient of demand. As I've said several times, make sure you write down the formula. The change in quantity demanded divided by the original quantity demanded times P over change in P. Always use the original price. We started at $9. Oops, sorry. We started at $9 and lowered the price to $8. The original quantity demanded at $9 was 40. The change in price is a negative 1. We'll use the absolute value of 1. And then the change in quantity is 40. So we have 360 divided by 40. The elasticity of demand then is greater than 1 because this right here indicates that the elasticity of demand is 9. We know then that lowering the price from $9 to $8, the elasticity of demand is elastic. Let's look at this demand schedule and look at the revenue that is brought in at every single price. If I charge a price of $9, the expenditures by the consumer, that's total expenditures, is $360, which is equal to the revenue that I receive from selling that product in the marketplace. If I lower the price again, it goes to $640, $840. 6 times 160 is 960. 5 times 200 is 1,000. But if you notice, below $5, as I lower that price, the total expenditures, which is also equal to the revenue that I bring in as a business, starts to go down. As a business owner, you have to decide what price you're going to charge for your product. $10, $9, $8, $7, $6, $5, $4, $3, $2, $1. Let's say you're the business owner. What price would you charge for this product? Most of you would say $5, but you might be wrong. Well, how can you be wrong if that's where the greatest total revenue occurs? Because I've taught you before that total revenue does not equal profit. I haven't talked to you about the total cost of production. And you know that profit is equal to total revenue minus total cost. And if I'm a business, am I in business to make a profit? The answer is no. I'm in business to maximize my profits. All this line gives you, all this demand curve gives you, is the total revenue. We haven't talked about cost. We're going to get into cost later on in this course. But you do notice this. From $10 to $5, as the price goes down, so as price goes down, total revenue is going up. That's the total revenue test. Or let's go in the other direction. As the price goes up, then the total revenue goes down. So as price goes up, total revenue goes down. Do you notice here at the bottom of the graph, as you raise the price, going from 0 to 5, the total revenue now goes up. As you lower the price from $5 to $1, then the total revenue goes down. This indicates this portion of the demand curve is inelastic, and that this portion up here at the higher prices, $5 on up, then this portion of the graph is elastic. What we have is different portions of a demand curve. Even though you see a demand curve downward sloping from left to right, there are different portions of the demand curve. And at $5, the total revenue is the greatest at 1,000. And so we call this unit elastic. This is called unit elastic. Let's see if you can answer some simple questions. Mr. Lopez is a butcher who recently raised the price of steak at his market from $1.50 to $2 a pound. Correspondingly, his sales dropped from 200 pounds per day to 100 per day. Figure out the elasticity of demand for steak at Lopez's market. What is the elasticity coefficient between $1.50 and $2? Go ahead and pause the video and figure this out. The original price is $1.50. The original quantity demanded, going from 200 pounds to 100 pounds, is 200. The change in quantity demanded is 100, and the change in price is 50. When you multiply this out, you get 150, 100 times 150, divided by 100, which gives you now 1.5, and the answer is 1.5. The elasticity of demand going from $1.50 to $2 is elastic. Let's prove this using the total revenue test. At a price of $1.50, the quantity demanded is 200, and at a price of $2, the quantity demanded is 100. We know here that at a price of $1.50, multiply 150 times 200, and you get 300. So the total revenue is 300. And here the total revenue is 200. As you raise the price from 150 to 200, the total revenue goes down. If you raise the price and total revenue goes down, you know that the product is elastic. Question 2. at 25 cents a piece, Mr. Blackman sells 100 chocolate bars per week. If he drops his price to 20 cents, his weekly sales will increase to 110 bars. Is the demand for chocolate bars elastic or inelastic? Prove your answer. Remember to write down the formula and then plug in the numbers. Go ahead and turn the video off and figure this out. The original price is 25 cents. The original quantity demanded is 100. If he drops his price to 20 cents, so there's a change in price of 5 cents, and his weekly sales increases to 110, so it's a change of 10. This would be 2.5 divided by 5, which gives us 1/2. So we know that the elasticity of demand coefficient is less than 1, and if it's less than 1, you know it is inelastic between those two price ranges and the price going in a downward direction. We can prove this using the total revenue test. P times Q gives you the total revenue. And so at a price of 25 cents, we know that the quantity demanded is 100, and at a price of 20 cents, the quantity demanded is 110. So that would be $25, that would be $22. As the price goes down from 25 to 20 cents, the total revenue goes down. We know that using the total revenue test, if the price goes down and the total revenue goes down, then the product has an inelastic